Everybody still with us? Okay, we're going to change the tone of the presentations, at least for this one. Now, my next speaker here, I have to say that I had the absolute pleasure of listening to Tony Wright give a presentation in a very unique venue. It was actually an indoor tennis court, I think. It was an indoor tennis court that was being used for an event. And I don't know, it must have been, 7 years ago, at least 6 years ago, 7 years ago. And at the time, I was preparing for the first series of talks that I was giving. I think it was in 2011, and the title of the talk was "The Shift is About to Hit the Fan." And but I knew I had something missing. I knew there was a piece of the jigsaw, and I wasn't absolutely certain what it was. And I went to this event in deepest Sussex, and I heard Tony speak. And Tony gave a presentation that was very much based on an absolutely seminal book. And I've been recommending this book for probably the last 5 or 6 years now. It was a book called Left in the Dark. Anybody familiar with this book? Yeah? Excellent. Well, it was an absolutely, and I believe is an absolutely seminal piece of work. And I'm not going to spoil it by talking any more about it. But it was listening to Tony's presentation that gave me that piece of the jigsaw. And when I read Left in the Dark, I absolutely knew where it fitted in. So my thanks very much for that. And if you want any royalties, tough. But absolutely amazing piece of work. And so anyway, I've been trying to get Tony to come to an AV event probably for a couple of years now. And 'cause he used to live in Cornwall, but now he's moved into also one of my adopted counties, Lancashire. So he lives in the wonderful old market town of Tomaden. Can you say it right yet?
I'm not going to embarrass myself.
Took me a long time to learn, or to be shown how to say Tomaden. It's pronounced or spelt Todd Morden, of course. It's an immediate indicator of whether you have any familiarity with the area. And then somebody's going to tell me I've just said it wrong anyway, probably. So I know that Tony's going to literally have you spellbound by what he has to share. He's going to take you into insights that I think are absolutely unique. So it's my great pleasure. Tony Wright.
Thank you, Ian. Thanks very much. Okay, thank you, Ian. Thanks for the invite. I have been trying to get my head around what goes on here and trying to find a sort of way in, because I'm going to talk a lot about what I would call sort of the basic biology of humanity. And it's sometimes divorced from what I consider the symptoms, which I know you're all interested in. And listening to one or two of the speakers today, I think the most obvious way in is talking about our perception, really, human perception, and the myriad of different beliefs. In fact, this conference is called The Alternative Viewpoint and implies we have many different viewpoints. And a lot of people are here today because they have strong reactions to mainstream viewpoints. And I really want to try and take you on a little bit of a journey to where the substrate of these kind of beliefs and ideas come from, and suggest that, in fact, our neural system, the substrate for our perception, has gone through some pretty massive changes in recent times, and they're not particularly good changes. And I think it can begin to explain the emergence of, I think it was maybe Brian that touched on it this morning, the sort of increasing prevalence of sociopathic and even psychopathic tendencies. And in addition, why generally, not including everybody, but generally we're so susceptible to being controlled, to being brainwashed, to being hypnotized, in fact. And I think there's a lot of answers to these questions lie in the basic biology and the basic neurology. Normally when I do these talks, it's usually sort of 4 hours broken up into 3 or 4 sessions. So I can't go into all the detail that I would normally, but there are some versions of my longer talks on YouTube if you want to fill in the gaps. So I'm going to sort of go on a little bit of a whistle-stop tour around what I think are the key pieces. You may or may not agree with my conclusions initially, but I'd strongly suggest you do some research and have a look. If you've grown up with certain ideas, they may not be based on solid evidence. So we'll whiz through a few slides just to try and give you a feel for what I've been doing for the last 20, 25 years, then hopefully slow it down a little bit and talk about some specifics, and then we'll see how we get on after that. So pretty big questions. I'm not suggesting I've got all the answers. I'm just hoping I'm starting to ask some interesting questions. Some questions, in fact, that Western culture and certainly Western academia have failed to ask. The most obvious one that comes to my mind is that we've never really questioned whether our perceptual equipment, our neural system, is actually functional. We presume it more or less works. There's a few odd things, or even a lot of odd things going on, but more or less it works. How does it work? That's certainly how Western science has approached our perceptual system. And in fact, that's very bad science, according to their protocols. You should never really presume anything. And certainly the equipment that you're using to design experiments, calibrate, and correlate the results, you should be rigorously testing that. You shouldn't presume it works. And of course, I'm talking about the equipment between our ears, because all the academics, all the scientists, and everybody else, we all share this equipment. It's regarded as one of the most complex things we know. We often presume it's highly advanced, but we've never really stopped to ask, is it working? Even though I'd suggest there's an abundance of evidence that some pretty serious problems going on. It's usually in everybody else. You know, I'm okay, everybody else is weird. Of course, everybody else is thinking exactly the same thing, so there's kind of something odd going on there. And I'm including some of the sharpest minds we have, particularly the people who kind of write the protocols and it's disseminated down through our culture. A lot of Western science has almost been taken as gospel, when in fact they're human beings with human frailties, human weaknesses. So there's quite a lot to sort of throw into the mix, and I have to remember all the bits and pieces myself. There's quite a lot. So I'm going to start just going through a few slides and try and give you an idea of some of the areas I've covered and suggest that they are linked. They may not seem linked, but I think they are linked. And eventually, a picture starts to form. It may take a little while. Hopefully, by the end of the talk, you'll have a better idea, or it may take a little bit of research afterwards. So it may be a case of just making some notes and perhaps wondering how on earth these pieces are linked. But after 20-odd years, I'm going to strongly suggest they are. So really, classic ancient question, really, who are we, what are we? And we've all grown up with the labels, we're human beings, or we're spirit of light, or we're apes, or whatever. They're all concepts, they're all beliefs. Doesn't mean they're not accurate in some way, but they're not the reality of what we experience ourselves to be, which is what I'm going to try and get at. It's very different having an idea of what we are and what we actually experience. And I've also, I suppose, been trying to figure out really what on earth is going on and come up with a diagnosis for what I call a human condition. Many people have looked at this. I'm hardly alone in thinking we've become clinically insane, actually. And that's an idea that's been around for a long time. It's not a recent idea. I think the symptoms are getting worse. And I think with the best will in the world, if there's even the remotest possibility that we have a gremlin in our perceptual machinery, and everything else we try and do is going to run into trouble, probably going to fail. And I think it's particularly poignant that we've inherited traditions from all corners of the globe, from very distant epochs. Regardless of the dogma around these traditions now, they tend to contain the same theme, that at one time we perceived ourselves radically differently, and something began to change, and we've slowly slid into a more animalistic state, a more delusional state. It's a common theme in every spiritual and religious tradition, and yet we ignore that at our peril. We presume, well, I'm okay. Just because we understand words like delusion doesn't really inform us whether we're deluded or not. So these are just a few things to sort of keep a hold of as we go through. I am going to start with a couple of summaries. I think just to provide a framework, and you can decide for yourself as we go along whether this framework does actually pan out, whether it's the information I'm going to share with you, or whether it's experiences in your own life, or what you see around you in your immediate circle of friends or family, or culturally, and so on. So pretty forthright start, basically suggesting one half of our neural system is in very poor shape, and it's perceptually dominant. In fact, I would suggest it exhibits quite serious symptoms of what might be called a form of dementia. That's how serious I think it is. And when you have mild mental health conditions, you're typically aware that you have a problem. Once the condition gets severe, you can lose any awareness that you have a problem. And I think collectively, I'm not saying every individual, but collectively, that's pretty much where we're at. I think we have a really serious mental condition, and we're blithely unaware of it. We just look around and we see some of the symptoms. We think it's everybody else's fault. I'll just build on that a little bit more, and then, as I say, we'll move through some slides quite quickly. And you'll start seeing maybe where these things join together. And this, I've tried wherever I can to draw on what would be considered fairly solid academic data. I don't always agree with the conclusions of the research for reasons that I will explain, but I think Western science has done a pretty good job in mining data. Endless projects, endless amounts of resources gone into doing all sorts of experiments, and we've generated a mountain of data. So much data we can't keep track of it anymore. And I kind of wondered quite early on in my sort of interest in this, whether there'd be a smoking gun in Western science data. Is there something already in there that we've missed because we're not looking for it? And you're probably, to some degree, familiar with the classic left-right brain research. It got a lot of press years ago, then it's been slowly watered down and partially dismissed in recent times. I'd strongly suggest you revisit some of that early research, because it's not about conclusions, it's about physical experience, perceptual experiences, split brain patients, absolutely fascinating stuff. But what came out of that, very briefly, and these are some of the leading researchers of the time, some of them still active, Michael Gazzaniga, I think he's still working in this field, and others. They basically came up with lots of data that suggested our perceptually dominant hemisphere has some very strange quirks indeed. And because they were not really looking for a pathology or a serious problem, they were just looking to see how it works, they were preconditioned to try and come up with, I guess, explanations that fitted the preconception, i.e. humans have become increasingly advanced, we're it's sort of almost at the pinnacle of our evolution, this kind of thing. But again, look at the data. Our left hemisphere has these traits of being perpetually in a state of denial, perpetually in a state of delusion. It lies, I think the term they like to use is confabulates. It lies all the time, and it's not even aware it's lying. And these are normal traits. We all have them. Very hard to see in yourself unless you're very honest when you look in the mirror. You see it in other people to some degree, and it's much more exaggerated in the split brain research, because in those kind of conditions, and there are other techniques as well, where you effectively dampen down one hemisphere or the other, or through injury or damage, it's taken offline, you start to see the traits of each hemisphere. And normally we're running in a sort of hybrid version, where we have a dominant left hemisphere, but it's moderated by what we call the subconscious. And it hides these symptoms to a degree, but they're still there, and experiments have been done to show that the sort of traits that came out of the split brain research really do exist in the normal population, as it's called. So we have a hemisphere, dominant hemisphere, that has these traits as normal. And of course the explanations were, well, it must be adaptive, there must be good reasons for this. There's even PhD papers written on trying to explain why humans are so good at self-deception. That's how absurd it's got. Nobody's ever asked the question, well, maybe there's a problem here, maybe our neural system isn't working. Never really entered the equation. Of course, and again, just to re-emphasize, the left hemisphere will tell stories. It will make up stories to fit its preconceived conclusions wherever it can, unless the evidence is so overwhelming, then it breaks and something has to give. And what you have to remember is all these researchers, of course, they all have a left hemisphere. They were researching their own left hemisphere. You don't read that in any of the conclusions. So they're coming up with this data about how the left hemisphere lies all the time. It will make up stories to get the conclusion it wants. And then they write up their data, and it's like, oh yeah, everything's fine, even though they've just produced data suggesting we have a serious problem. So again, please check this out. I have drawn on this data, but check it out for yourself. A lot of it's online. And if you look at it with fresh eyes, drop your preconceptions and just look at it as if it was for the first time, the traits of the left hemisphere. Oh my God, it's really scary. And it ties in wonderfully well with these Arcadian mythologies, these oral traditions, the spiritual traditions, right through into the kind of more sort of religious ideas that are still around today, particularly when they talk about sliding into delusion. I find it fascinating. It's not proof. It's fascinating that there's an ancient tradition and then modern neurology's turned up exactly the same thing. And to me, it should have sent shockwaves. We should have been, oh my God, let's drop everything. We haven't a clue what we're doing. But in fact, we're so deluded, so much in denial, we just keep on going, which is kind of almost what you'd expect. So, again, back to the sort of story. A lot of people have been looking at this, how we get from apparently living in the forest for a very long time, not much going on there, primitive, didn't invent anything, and eventually we end up with all sorts of wonderful technological inventions. Everything's fantastic, up to modern day, where bigger, shinier, faster. Of course, the humanity in this is shrinking all the time, and we become obsessed with technology and our technological achievements. Classic left brain symptoms doesn't really have much humanity left in it. The humanity we tend to see, again, is filtering through from the less damaged hemisphere. So we become obsessed in measuring ourselves by technological achievements, regardless of the cost, the human cost. And we know it goes on. We're all collectively responsible. The equipment we're using to put this presentation on, somewhere down the chain of supply, it includes massive poverty, children down mines. We know this, and yet we still continue with it. And the obvious contradictions, things are getting very advanced, and yet one of the most advanced things we have are the ways we kill each other. Most of our resources go into developing ever more efficient ways of killing each other. And a lot of Western economies are propped up by defense contracts. And we know this goes on. So these massive contradictions and juxtapositions, and by degrees, some of us are aware of this, and we're very unhappy about it, but nevertheless, the juggernaut goes on. And the human cost, even in allegedly the most advanced conurbations, not that I personally think they're advanced, but this is a story we've grown up with. You look, and there's human misery all over the place. And even when it's working, the reality when you actually speak to human beings, it's much more about this disorientation, bewilderment, stress, degenerative disease, running faster and faster, getting less and less. And this is just probably the top 5 or 10% of the human population. All the rest are propping these systems up. So we have these crazy systems built still on slavery, just a different kind of slavery, and it's really about self-destruction. Western culture is really engaged in the act of self-destruction. We're destroying everything, including ourselves, and calling it advanced. If that's not severe delusion, I don't know what is. So these are just a few symptoms and a few clues along the way. Prior to Western science tending to dominate, our natural history was accounted for in a very different way. We had these probably very ancient traditions, already touched on it, suggesting that things were very different a long time ago. Now, a lot of people tend to dismiss that as being sort of nostalgic and probably the outpourings of a primitive mind. That's a fair argument, but I'm going to get onto some mechanisms that suggest actually that's not the case. But nevertheless, dwelling on these traditions just briefly, as I say, they don't talk about things being, oh, well, you know, we live communally, things were a little bit better. They talk about a very different state of mind. And the terms that have come down to us are typically in the sort of category of rapture, divinity, really powerfully different states, and a real sense of connection, a real sense of oneness. Terms, of course, bandied around today. And we clearly still have the wiring for these experiences because people still have glimpses of these experiences. So something in our wiring somewhere can facilitate those kind of experiences, sometimes spontaneously, often in relation to particular incidents, extreme stress, which can overload the left hemisphere and it gives up, or through particular practices and techniques from many of these traditions, whether it's from yoga, meditation, kind of Trappist tradition, so not speaking for weeks on end, shutting the left hemisphere down, these kind of things. Using plant medicines and related chemicals. Remember, our brain absolutely depends on chemicals to work. For me to stand here and do this, there's a cascade of millions of chemical reactions going off. Our brain is a drug machine. It needs drugs to work. What kind of drugs? Of course, that's open to debate. But some of these chemicals that traditionally have been used to try and access some of these states, lo and behold, and I'll come to a slide later, they tend to differentially stimulate the right hemisphere, the expansive classes of drugs. Some drugs tend to fuel the left hemisphere, thinking more of your cocaine type, speed type drugs, but the psychedelics, as they're called, tend to stimulate the right hemisphere. And they have a long history of use, and they're related to connecting to this lost state. Of course, they can be very frightening because they involve the left hemisphere having to let go of control, and that's one thing it does not like to do under any circumstances. It tends to fight and gets very frightened. Anyway, as you can imagine, there's lots of information that I could talk about with all of these slides. I'm just showing you pieces and suggesting all of these pieces start joining together, and there's a wealth of data and information to support them. Once you start asking different questions, particularly whether actually my brain does work, is there a problem with it? It's quite a challenging idea. Left hemisphere doesn't like those kind of challenges. It likes to be highly advanced, everything's fine, I'm in control. So we tend to shy away from those possibilities. And if there isn't anything wrong with our mind and our brain, absolutely fine. But if there is, until we actually recognize that, until we embrace that, then I think we're stuffed. This is just, again, hinting at altered states of consciousness. We typically, in our culture, we grow up with very limited parameters, who and what we are and what's acceptable. And yet, again, littered throughout history and even currently, plenty of evidence that our neural system is capable of radically different states of being. And they're not just some, archetypal hippie like myself sat in the corner taking some drugs and can't do anything. There's a lot of evidence coming out now that these are highly functional states, cognitively, and increasing evidence of people microdosing, extreme sports people, this kind of stuff, enhancing physical performance, all sorts of things. So suggesting that tweak the chemical regime, tweak the structure, imagining our neural systems like a big lens, tweak it a little bit and you get a different result. Well, lo and behold, it's not a great revelation. So again, I'm suggesting we still have some wiring there for some radically different states of being. And I can't imagine that our current culture could be much worse. It would take hundreds of brilliant people to design something so horrendous. So why on earth we legislate and are determined to hang on to the neural chemical regime and neural structure we currently have when it's killing us? We already know a lot about what to do to change it in a positive way. But of course, the left hemisphere is terrified, and it would rather hang on to the bitter end and go over the cliff than admit we might need to change. Again, coming out of the split brain research, and again, please revisit this. If you've already looked at it, look at it again. And going back to what I touched on earlier, beliefs. We all have our beliefs, we all have our concepts. And there's nothing to say concepts can't approximate reality. They aren't reality, of course, but they can be a really good approximation. or they can be miles away from reality, and we tend to identify with them, and then we tend to start fighting each other because we can't impose our beliefs on each other. And there must be, I don't know, hundreds if not thousands of different belief systems now. And unless the cosmos, the universe, is even more bizarre than I think it is, it doesn't make any sense, particularly when you look at right hemisphere experience, and particularly the deeper it goes, there's a common theme comes out. And when I say a common theme, I don't want to sound like it's a contracting theme. It's an expansive theme, but it has similar themes regardless of history, regardless of culture, even regardless of dogmatic belief. When people have these powerful experiences, and they're particularly powerful, they start trying to communicate the same old story. When I say the same old story, it's a story we desperately need again, and it's to do with absolute, profound wonder and joy within and in connection with everything and everybody. So, which of these realities makes the most sense? Our dominant reality where we're defending our beliefs, or this otherness that we're afraid of that tends to suggest everything could be an awful lot better, and again, I suggest also very functional. A simple exercise, again, trying to define who and what we are. It's quite a good game. You take away your name, your nationality, all the concepts you associate with who you are, your job title, everything, and what's left. What do you actually experience? And the left hemisphere doesn't have much experiential capacity anymore. It'll spurt out some labels as if that means something. But we do get glimpses of something else, whether it's when we fall in love, when we have children, when we take certain chemicals, whatever it is, something else comes through, and it can be quite profound and amazing. So again, coming out of the split brain research, and it was one of the things that caused a lot of academics a lot of problems. In fact, I'd go as far as saying there was a great eagerness to dismiss classic left brain research because it didn't make any sense. Why would we have these vastly different capacities, and particularly where we seem to have a dominant hemisphere that had very few capacities other than it could speak, which we've been led to believe is actually very advanced, and I'm going to suggest it's the opposite. And it invents conceptual versions of reality. So we've been sold the idea that that's a good idea. And yet we have another sense of self that rarely gets out. Sometimes get glimpses of it in, as I say, some of these approaches. And it has a very, very deep sense of experience with many, many insights and abilities, just not the sort of things the left hemisphere recognizes or values. But this is solid data. 2 selves in each skull. Yet we typically, most of us refer to ourselves in the singular. We don't usually go around saying, well, we had this kind of a day, or we are doing that. But it is in there somewhere. Some of us do have more of that experience. And actually it can be troubling. If you have a dominant left hemisphere, it's like a jailer. It's got something locked in the basement it doesn't want you to know about. Sometimes it sneaks out, and it's quite frightening. And we end up getting treated and put in funny farms because we're starting to talk about different things that don't fit the left brain idea of reality. Again, just jumping from one slide to another, it may not be particularly coherent just yet, hopefully it will be by the end. Human sleep. There's still a lot of mystery around sleep, still a lot of big questions. What on earth is it for in all species? But humans display some relatively unusual traits in sleep. And what I'm going to suggest, I'm just going to throw the conclusions at you, is that because of the changes in our brain that I'm going to get to in more detail, I suppose I'd call them degenerative changes, we have 2 sleep requirements. We have a left brain sleep requirement and a right brain sleep requirement. It's as if the left brain, although it's in charge, it has weak batteries. Can't run very long before it starts losing control. The right hemisphere, not so dysfunctional, has stronger batteries, and immediately starts to make sense of a lot of these dichotomies. Even things as simple as, for example, we tend to be more emotional when we're tired in the evening. We tend to socialize more in the evening. It's not so easy when you get up in the morning and your left brain's fully charged. It doesn't really want to know because it's kind of scared and it'd rather be in its rigid techno world. But by the time it's getting tired, it's not able to control quite so strongly. We start relaxing a little bit, start engaging with each other. Of course, as the batteries weaken, the feeling of tiredness becomes quite powerful. You get really powerful symptoms like speech starts to slur, become clumsy, uncoordinated, and most of us head for bed. Well, our left brain does. It's like, got to get some sleep. People can even get quite angry if they don't get enough sleep. Weirdly enough, there are traditions that talk about staying awake to get to a very different state of mind. They're embedded in some traditions and haven't had much attention. So, for example, prolonged meditation is a form of sleep deprivation. It's kind of hinted at in the Buddhist tradition, the Buddhists meditating for 7 days and nights. Well, unless he fell asleep, he was also being sleep deprived. It's part of Vision Quest, staying awake until you get into that visionary state. It's even in the Epic of Gilgamesh, kind of classic story of the initiate trying to get to the lost state of consciousness of the ancestors. One of the final tests was to stay awake for 7 days and nights. And in this story, the initiate failed, and some people interpret that as an indication of a general fall from grace. So I got interested in this and did quite a lot of experimentation in the early 90s and ended up doing about 2 years of nearly solid sleep deprivation, 3, 5, up to 7 days and nights. A night or two sleep, start again. Absolutely fascinating. Can't go into loads of detail, don't have the time, but I ended up going to Manchester University and being tested because one of the classic ideas is if you stay awake, you start being very delusionary, and did a lot of measurements, a lot of tests, and I said, look, if I stay steady state, that'll be interesting because I should be in a mess. And they agreed, and they thought, I was going to end up in a mess. But actually, all my functions improved. It's the only study I know of that's happened, and they were going to publish it, but because they couldn't explain it, they got cold feet and said, we'll have to run it again. I said, fine. We've got no money. So it's the only data I know of showing that correlation, but it's never been formally published. Anyway, other things coming out of sleep, sleepwalking. So we're asleep, and yet something else can take our body, run off with it, and do quite complex things, including driving, going to the fridge and eating, robbing banks, although that might just be a clever defense, I don't know. But quite bizarre. Then dream insights, I'm sure you've come across this. Lucid dreaming, a lot of weird stuff behind the veil. How do we explain that? What's going on? Again, sort of throwing quite a broad net here. I'm saying there's physical symptoms as well. This all does come back to our neural system, our consciousness system. And I usually say this at the start of the talk, I'll say it now, I'm not saying we are a brain at all. It's still a massive mystery. But the evidence that our brain is really hugely implicated in our perception and changing the neural structure, the neurochemistry, even a tiny bit can have a massive impact. So it has a role. Exactly what that role is, who knows? I tend to see it more like some kind of weird lens, and something comes through when the lens is aligned, and it doesn't if it's not aligned. That's just my own personal view. But I just wanted to say I'm not saying we are a brain. I know it's a very reductionist thing. So getting to handedness. Again, it's another mystery. Lots of papers written on it. Something to do with spear throwing and God knows what else. I've come to the conclusion that handedness is simply a physical symptom of lopsidedness. Simple as that. Why on earth? I'm quite strongly right-handed. Interestingly, I'm not when I stay awake. And the Manchester results bore that out. My left hand got better than my right hand, became more dexterous. But typically, most of us have one hand that doesn't work very well. You try and do fiddly things with it. You try and do things that you're not used to, and it's really awkward. Try writing with your other hand. Some people are ambidextrous, quite unusual, but does exist. But most of us have a hand that just doesn't work very well. Why on earth would we have that? What's the adaptive benefit of having a hand that doesn't work very well? Just something to think about. I show this slide at other talks, and it's really about it's a comment on the desperate efforts to explain human origins within Western academia. and all the, well, there's maybe 3 or 4 main theories, and they're slowly falling apart. There's this kind of idea that nothing went on in the forest, even though, interestingly, tropical forests are one of the few places you get large, unusual brains. That already exists as a mechanism in there that we don't understand. And it was somehow when we came out of the forest, desperate to get away from a place that was relatively safe, into these harsh environments, whether it's savanna, coastal dwelling, wherever else it was, and that somehow drove our intelligence and increased our brain. But when you look at the basic chemistry, there's just nothing in the savanna to build and run a very complex neural system. If there was, they would have emerged there before. In fact, neural tissue is very expensive to build, it's very expensive to run, and actually, it's not really essential for survival. There's many, many species have survived apparently for millions and millions, tens of millions of years with minuscule neural systems in similar environments. So what on earth is this huge brain for? Where did it come from? Why did it emerge? Well, it struck me quite early on that people talk about the human neural system being one of the most complex things we know. We also have come to the conclusion collectively, Western science, that tropical forests, from a molecular ecology point of view, so the chemistry, again, the most complex environment we know. Tropical forests off the scale in terms of complex biochemistry. So is it a huge leap to start thinking, well, most complex neural systems, most complex ecology, is there a connection? Oh, no, it's when we came out of the forest, went to these hostile environments, there's nothing there to build the brain, nothing there to run it, that's where it happened. Doesn't make any sense. We'll get to that a little bit more in a minute. Kind of touched on this already. I guess a lot of people here are interested in what we call higher function. I'm going to suggest it's lost function. We once had this, and it's virtually all gone. And the relics of it live in the other hemisphere, and it's hard to get at. But these are important questions, I think. If we have the wiring for this, if we have that capacity, and it's still glimpsed, as I say, using these approaches or techniques or spontaneously, where did the wiring come from? What did it evolve for in the first place? And why the hell can't we get access to it? What's the point of having these amazing abilities when most of us spend most of our lives in a relatively mundane state? It doesn't make any sense. And again, I'd suggest the ancient traditions, once you kind of just distance yourself a bit from the dogma and the beliefs, but just look at some of the data and some of the kind of commonalities, they all suggest that a long time ago, we did have access to these states. And they often talk in very specific terms, some kind of ecological disaster. And from that point on, we've had sort of periods of degeneration followed by further periods of degeneration. They don't say things went a little bit wrong. They actually talk in, I think the classic ages of man is one way to look at it, where there's been several major crashes. And we're at the wrong end of that story. I know it's challenging, but when you look what we're doing, actually, we shouldn't be surprised at all. You know, I don't think there's any evidence that we've made more of a mess of things than we are now, even though we're so advanced. And some of these ancient traditions, they actually are quite specific. And again, I think it correlates well with modern neurology. They go as far as talking about there being this difficult to articulate, of course, but this sort of sense of total connection. And it was a divine state. It wasn't the kind of state you'd go, well, I've had enough of that now, I'm going to go to the chip shop or something. You'd stay there forever if you could. And then something happened, and a different state started to emerge, and eventually usurped this ancient state. And this new state is closer to the common state we are in now. And it sounds to me like it could correlate with the emergence of cerebral dominance. You have two hemispheres working in perfect unison, and we'll talk about that in a minute. System starts failing, one side starts failing more than the other, but that failure brings with it loss of function, loss of perception, which is frightening, and that's one of the reasons it starts to take control. So the lesser function takes over, even though it's losing function all the time, and we end up with a state or a neural system with very little capacity, but great capacity for lying. Again, touched on this already. Most of us have grown up with the idea that speech is one of the wondrous achievements of human evolution. And speech is left brain, not language necessarily, but speech. And yet, very simple analysis, singing, way more complex than speech, carries way more information. Why would we trade singing for speech? The left hemisphere, certainly by the time we've gone through puberty, and we'll talk about why that happens, typically finds it very difficult to sing, or when it does, it doesn't sound that good really. And yet, we have buried in us a singing voice. Pretty much everyone. Can be hard to find, and interestingly, it can come out maybe when you've had a drink. Some people sing a lot better when their speech has started slurring because the alcohol is an anesthetic, shutting down the left hemisphere, hasn't quite shut down the right hemisphere, as long as you don't drink too much, and people burst into song. And sometimes it actually sounds pretty good. And it's a great form of communication. And I've said this in several talks. I've never risen to the challenge yet. But if I had the resolve, shall we say, to sing this operatic style, you'd find it far more entertaining, and the information would be much better. I'm just too much of a coward. But that, again, tells me something and should tell you something. You know, we have a far better communication system, and yet we bought into this idea that the thing I'm doing now is somehow more advanced. And of course, singing and complex movement and dance, they were part of many practices, because it's a case of you can get the tail to wag the dog. You stay in your speech mode, and you're helping the left hemisphere stay in charge. Push yourself out of that. I'm not saying it's not challenging, but it can be done. The ancient idea of trance dance, nothing new about it. Singing, dancing, moving. The left hemisphere is useless at that. It's terrified of it. It can manage a very simple beat, very simple rhythm. That's about it. You want to move into complex stuff, you have to engage the right hemisphere. And by doing that, you start bringing through some of the other traits, and it feels bloody amazing as well. It should be, enforced on us, but of course it's actually legislated against, because it's scary. So again, just more clues. Each one of these slides has a whole story about it. I'm just repeating myself now. I'm just providing you little glimpses of the areas that I think all join together and start coming together as a kind of collage of what may have happened. Slightly more controversial, but quite interesting. And there's elements of male fertility and male sexual function that I could touch on as well. But in some ways, this is more interesting, because what I'm going to get to is that for the longest period of human evolution, according to Western science and echoed in these ancient traditions, there were two reproductive systems co-evolving. A typical mammalian reproductive system, which there's been a lot of study on, and, bizarrely enough, the angiosperm reproductive system, the angiosperm female reproductive system. So what do I mean by that? The flowering plants, the trees of the forest, they're swollen female sex organs. That's one of the unique things that jumped out at me. I have a little bit of training in plant sciences and so on, and then I got interested in more human-related anthropology things. And looking at all the data, it's like, well, there's a lot written about this, but nobody seems to have made the connection that if you have a relationship with the forest, not only a relationship with the forest, but a symbiotic relationship with the trees, which is accepted, it's based on seed dissemination, what you're actually doing is ingesting the female reproductive organs of the angiosperms. So that's how we were evolving. We were, on a daily basis, eating the sex organs of a whole other kingdom. Now, if that's not really weird, I don't know what is. Pretty damn unique in evolutionary history. Of course, lots of species, plant species, produce fruit in all sorts of climates, and lots of things eat fruit. So you think, well, there's nothing unique in that, and to some degree, that's correct. However, when you look at the non-seasonal tropical forests, you've got savanna, woodland, seasonal tropical forest, which is very rich biochemically, but still seasonal. There are niches within that, depending on the climate regime of the time, that can be described as non-seasonal tropical forests. They're typically on the equator, but not all of the equator. And there's no real difference, day or night, any time of the year, or day length, which is important. It's a very stable niche, as long as it's protected by these kind of outliers of forest. And that's one place where you can eat fruit 24/7 for hundreds of thousands, even millions of years. You can form a stable relationship with the female reproductive organs of the flowering plants. And lo and behold, the physiology fits out very well. We're all wearing clothes in here. Now, I know in more recent times we've become really weirded out by our bodies, and that's all really kind of creepy and stuff. But that aside, temperature. We need a minimum of about 22 degrees to feel comfortable. That's the minimum. And we're quite happy up to about 30, 35. Exactly what you'd get in these kind of environments. I just think it's interesting that our physiology fits this, and it's the only place you can eat fruit for long periods of time. We're going to get on to why that might be interesting in terms of our brain, but briefly, the hormonal effects of fruit, plants and animals, yeah, they're really different. Well, actually, we've grown up being taught the differences between plants and animals, 10, a dozen, 20, vast array of similarities. Same DNA molecule, vast amount of similarity in chemistry. The main difference is mammals, most animals, produce a fraction of the chemistry of plants. We're like parasites. Plants do all the hard work. They do all the heavy lifting. One species of tropical tree probably produces more novel chemicals than we're currently even aware of. That's how complex they are. That's why the pharmaceutical companies are always in the tropical forest looking for things to heal us, except they won't use the natural stuff. They'll make a synthetic copy that has side effects, charges a shitload of money, blah, blah, blah. But the point is, that's where all the cool chemistry is. And that's where we evolved. And it's accepted we had this relationship with fruit. So what I'm going to say very briefly is two reproductive systems co-evolving. It had some very strange effects on the human reproductive system. And what we have now, with a lot of our systems, is a system that doesn't work very well anymore. So, for example, menopause, almost unique to humans. We kind of run out of fertility long before we die. And then we have classic monthly ovulation and so on, lots of explanations for it, a lot of kind of taboos around it. But if you look at how these things work and you start kind of extrapolating and reverse engineering, you put this chemistry back in, you have a symbiotic reproductive system, in fact, a symbiotic organism. I'm going to get to that eventually. I'm going to say basically humans were symbiotic, and particularly our new brain. But focusing on the reproductive system, it's like all the hormonal elements have gone, and we're now left with a very basic mammalian system. And yeah, we've got synthetic HRT and all this kind of stuff, which is, for the most part, potentially very dangerous. We had permanent hormonally active chemicals flooding through us 24/7 from conception to death. And what I think is happening now is this archaic estrous cycle's re-emerged because we're missing vast amounts of hormonally active chemistry. So a bit challenging, something to think about, but have a look and look at the data. It does seem to fit. How are we doing for time? Okay, another thing that comes out of sort of researching humans, and including myself, it's amazing how frightened we all are, particularly in our culture, but increasingly elsewhere. And the left brain doesn't like to own up to being frightened. It will create any story and lie to itself and everybody else. But most of us are actually really frightened to move out of the accepted norms. I could do this talk naked. I would probably get arrested, and some of you might laugh or run away. But when you think of the rules that we all follow that are entirely arbitrary, we're terrified of breaking them, terrified of moving away from them. And fear is a typical symptom of mental ill health. We're actually frightened. We don't even know why we're frightened. We are too frightened to let anybody know. If we look in the mirror and we're honest, we can see that. But we all play the game, we all collude, and we don't cross each other's boundaries as much or as little as we can anyway, because we don't want to provoke a reaction, and we're all in it together. We're all kind of playing that game. I was having a chat with somebody, I think yesterday, and it's quite fascinating, chatting to people about this one-to-one, all over the place. And the vast majority of us seem to have a voice in our head. Now, it's been written about, it's not new. Remember, speech is left brain. And if we're not doing this audibly, it's going on all the time anyway. And who of us would share that commentary, even with our closest friends or our partners? It's usually pretty nuts in there. And we've all got it going on, but we keep it hidden. We all collude, we all play the game. Now, again, if that's not a sign of serious mental health, I don't know what is. Or maybe some people here don't have that, but I've only had one person ever put their hand up and say, no, I don't have that at all. So everybody's got a mad voice in their head, coming up with crazy, weird shit all the time. You're scared to tell anybody. We're all doing it even right now. What's that all about? Maybe it's fine. I don't know. Again, touching on this, we've become increasingly, collectively, frightened of pleasure, particularly profound pleasure. It's okay to get excited about buying a new car. It's okay to get a new computer and get excited. Anticipation, it's not really pleasure, but that's okay. Deep pleasure, profound pleasure, our left brain doesn't have the wiring for that anymore. If you want to experience really deep, profound pleasure, you have to let go and move to a different place. But of course, that's about losing control. So individually and collectively, we've begun to legislate and prohibit anything that can change that sense of control. Even simple things like music and dance. And certainly when you talk about altering your consciousness in a way that feels good, ooh, no way. You have to stay exactly how you are. And classic example is sex, sexual pleasure. There's you can see in various cultures that if sex weren't absolutely essential for procreation, it would be banned. That's how nuts it is. And yet there are traditions that are being slowly rediscovered in times when we weren't so hung up about all this, where sex and sexual pleasure was used as a way into altered states. Because to experience that profound pleasure, you have to shift. And then it's not just pleasure, it becomes divine pleasure. But that's not part of our culture anymore. It's kind of scary and frowned on and pretty weird. Why? Why on earth? I mean, it's fine to build tanks and build fighter planes and kill each other, but to embrace pleasure, and it's all classic hippie stuff, I know, but looking at the mechanisms, it's not part of our left hemisphere's capacity anymore, and it's terrified because in order to feel that, it has to let go. Collectively, our health, not too good anymore. It's quite a major understatement. Ancient mythology, again, suggested that we lived very healthily, very, very long lives. I can't prove that, but it's interesting those traditions exist. There's kind of it's a bit of a closed loop, but interesting that if our distant ancestors did live in a very different state, they lived longer, they lived very healthily in a relatively benign environment, and believe it or not, tropical forests, deep tropical forests, very, very dense canopy. You don't get grass growing. Why is that important? Because you don't get huge herds of grass-eating herbivores. And what do you not get when you've got huge herds? Predators. So in the deep forest, it's relatively benign. It's not that there's nothing there, but it's a relatively benign place to be, as long as the forest stays intact. And these ancient traditions hinted that we lived pretty benign lives in a state of perpetual wonder and joy, lived for a very long time. In fact, the sort of Judo-Christian tradition, although it probably originated much earlier, Sumeria, or even further back, I don't know, but it's fascinating, and I quite like to use it at least as a metaphor. Whether it has some reality or not, I don't know. Classic Garden of Eden story that's, followed Western culture's dominance. our very genesis was something to do with living in the forest and eating fruit. And most of us, when we think of fruit, yeah, healthy snack. But once you recognize, no, symbiotic relationship with a female reproductive organ suddenly all takes on a different meaning. And we're going to get to a little bit of the specifics, I hope, about the impact fruit has on typical mammalian biochemistry, particularly our own hormones. This is what I'm hinting at here. We're now, for the most part, not in a symbiotic relationship. We're a standalone mammal, and our left brain likes that. Look at us, we're very advanced, we don't need anything else. Unfortunately, mammalian genomes, they're not very complex. I think there was a lot of excitement about the Human Genome Project. We're going to analyze human DNA, and we're going to find all these codings for weird and wonderful things in our big brain. You'll notice that there's not really been that much talk about it since the human genome was deciphered, because it's actually a pretty basic mammalian genome. And what do basic mammalian genomes do? They build basic mammalian systems. Great for survival. Usually they don't have very big brains. Usually not that smart. Can be quite aggressive, very survival orientated. That's fine, that works. But if for the longest part of evolution we were flooded with chemicals that changed the way our DNA was read, it all starts pointing in a different direction. And one part of our immune system, the thymus gland, turns out is very, very sensitive to hormones like testosterone and estrogen. And it stops developing quite early on as puberty starts. And it looks to me as if when we were in this relationship with the forest, flooding our system with the reproductive chemistry of the plants, it dampened down our own powerful mammalian hormones, things like estrogens and testosterone, and allowed our immune system to develop in a radically more powerful way, kept us healthy in a very much more powerful way for much longer. Now I think our immune system's in dire straits. I touch on this as well. I'm sure at least some of you have been interested in the pineal gland and some of the recent research and so on. Fascinating gland, produces, or known to produce at least a couple of chemicals, melatonin and pinealine. Some interest in DMT, it's still a little bit shaky. Never mind. Melatonin and pinealine, powerful hormonally active compounds. Lo and behold, they have the same effect as fruit. They dampen down things like testosterone and estrogen. And interestingly, fruit contains chemicals that can stimulate the pineal. Used to be thought that the pineal was bulletproof. It couldn't be affected by external chemistry. That changed when people were being prescribed monoamine oxidase inhibitors like as antidepressants. Turns out monoamine oxidase inhibitors can stimulate the pineal and get it to produce more of these chemicals. Well, lo and behold, in fruit, there are classes of compounds, particularly called flavonoids, and many of those have monoamine oxidase inhibition capacity. They act as mild to moderate antidepressants, if that's the way you want to look at it. They enhance neural function, and they can stimulate the pineal. So we're living in an environment where the pineal was being stimulated by the diet we ate. Now it's not. So I've started to talk a little bit about hormones, and really what I'm really going to talk about is this relationship we had in the past with the forest and the reproductive organs. The biggest impact it had was moderating and inhibiting our own mammalian hormones, the ones I've mentioned already that we're probably all familiar with, estrogens and testosterone. And estrogens and testosterone play a massive role in our development, in every aspect of our development. They effectively read the DNA. They tell the DNA what to do. I'm simplifying it a little bit, but it's not so far off. So you imagine we spent forever in the forest, and we evolved new traits while in this kind of semi-benign environment, flooded with these chemicals that were dampening down our own typical mammalian hormones. Something happens, climate change, forest dries out, suddenly no more reproductive organs. Doesn't mean we die, but it means we're suddenly exposed to our own mammalian hormones. And what do? They're telling the DNA to build this standard mammalian model. That's what they're trying to do. And as we've lost that protection, those hormones have come to the fore again, and they're slowly achieving that result. And I'm going to suggest that the emergence of patriarchal culture is in fact a symptom of neurological damage, particularly with males, because testosterone plays a big role in this. It's not just a male hormone. Women produce testosterone as well, so I don't think you're getting off the hook entirely. But testosterone really has a very powerful impact on neural development. In fact, this paper's written on it, and it seems to affect the left hemisphere more. Surprise, surprise. And free from that buffering, our hormones are now trying to sculpt this typical mammalian brain. And as it's progressively got worse, as we've got a more primitive left hemisphere, particularly males, what comes with that? Loss of function, fear, need for control. You see the emergence of a different societal structure. It's not more advanced, it's not an experiment, it's a symptom of neurological degeneration. I don't know if that sounds too radical, but I think I can get away with it being a male. So I'm going to suggest hierarchy and patriarchy, that classic autistic lack of empathy and so on, are symptoms of neurological damage. And it's just that bit more severe in males, hence that rise in the sort of, I think I touched on it earlier, sociopathic, psychopathic behavior. There is a spectrum. Not everybody's affected to the same degree. So you can take some comfort in that. So quite a few clues there. I'm going to try and get into a little bit more specifically how this works before I run out of time. Really going back to the drawing board, looking again at how this might work, forgetting the kind of standard ideas, but looking at the data. Data is very good. And looking at our origins, and again, the thing that jumped out at me was this symbiotic relationship with the reproductive organs. It's established, it's accepted, different disciplines, different papers, nobody's talking to each other. And beyond the most complex environment, what we've really got is this special relationship. And in a nutshell, what I'm exploring at the minute, a way of explaining this, if you think about typical human life cycle, or most mammalian life cycles, you have conception, in utero development, then you have fetal, post-fetal stage, juvenile stage. Now, if you think about the juvenile stage of most mammals, radically different from the adult stage. So different, in fact, that you could almost say they're different species, even aggressive species. If you look at predatory animals, when they're very young, quite playful, a lot of fun going on there. They're not as aggressive. Yeah, they kind of rough and tumble stuff going on, but they're not anything like aggressive as the adults. And we see it, of course, in our lifespan. We have this juvenile phase, and it's not as clear to see in Western culture, I think, because of extremely poor diet and all sorts of other factors. But looking at the more positive elements of classic ideas of the juvenile window, a lot more empathy, a lot more compassion, a lot more fun, the psychology of fun, and a voracious and insatiable appetite for new experience and learning. Why? Because neural tissue in a juvenile form is incredibly plastic, and it just soaks stuff up. Can't throw enough stuff in there quickly enough. Now, in most species, it's a brief window. You learn enough to survive, and then the sex hormones cut in, and it turns you into a reproductive machine. That's a classic sort of way these things go. And in that process, the hormones, they're creating a sort of reproductively mature species, a mammal, but it changes the brain structure. It differentiates, it becomes more rigid and compartmentalized. You lose this uniform juvenile there, and it becomes a more adult brain. And it runs to a greater degree on programs it's already learned. And that works for most mammals. It's fine. It's a successful approach. But I'm going to suggest what happened with humans is something wonderfully rare was lost. Basically, this relationship with fruit inhibited our maturation, stopped us maturing in the way we normally would have done, and we were becoming adult size, I think, but our physiology was becoming more and more juvenile, to the point where we were just about able to reproduce. And the cool thing that came out of that was a kind of brand new layer of juvenile neural tissue. We call it the neocortex. It's been the source of great mystery. Why did we grow this big new layer of neural tissue? We didn't need it to survive. It's huge, it's expensive to run. As it happens, fruit's rich in simple sugars, which is exactly what it runs on, so it's not a big deal when you're in the forest. But it brings with it the possibility that we retained those juvenile features, voracious appetite for new experience. Well, if you retain that all your life, you become hyper-intelligent. You have phenomenal intelligence. And again, it's hinted at in these ancient traditions, vastly more intelligent, probably a very different kind of intelligence. And that juvenile phase was entirely dependent on this symbiotic relationship. The fruit inhibited the normal developmental mechanisms that allowed a new juvenile layer to emerge. And interestingly enough, when you have juvenile neural tissue, it runs the hormone system in a juvenile way. It's kind of called the neuroendocrine system. So children, young children, they have a different hormone regime to adults. They're producing more juvenile hormones. It keeps them juvenile for a period. So that combination of fruit and a new juvenile brain starts growing. That's when the brain grows before we hit puberty. So it's expanding. It's juvenile tissue. It's running a juvenile neuroendocrine system. Starts feeding its own expansion. And one of the big mysteries, a lot of people are fascinated by why we've got such a big brain. I don't think size is everything, but I think size, the mechanism that gave rise to the big brain is the same mechanism that gave rise to a juvenile brain, the one and the same thing. And a lot of fascination with this rapid expansion. Our brain tripled in size in about 2 million years. Extraordinary, almost unique. Equally interesting is it stopped expanding roughly 200,000 years ago. Those dates may change, the fossil record may change, and it's been shrinking. Been shrinking ever since. We've been losing neural tissue ever since. And I think we've been losing the very best neural tissue, the outer, most juvenile layer, the layer that gave us all these unique properties. It's been shrinking, we've been losing it, and we've been moving back to a more primitive brain structure, imperceptibly through the generations, but a cumulative effect. And when you look at this sort of basic diagram, it mimics typical mammalian lifespan and our lifespan now, where our brain expands when we're young, stops expanding mid to late teens, early 20s maximum, and it starts shrinking, and we start losing function. And eventually, we have forms of mental ill health. And I think this is exactly what's happened in evolutionary terms. We went through this phase where we were held in a juvenile state. That juvenile state kind of bootstrapped itself up. We grew an enormous juvenile brain with all these unusual traits. And then the forest disappeared. We were exposed to our own hormones, and it stopped expanding overnight. Very difficult to explain all those things unless it's a real-time effect. It's not an evolutionary thing in the classic sense. It's not locked in our genes. It's messing around with hormones. It's like we were engineered by the plants. We lost that engineering. We ended up reverting to a more primitive type. And this tries to explain it in a little bit more detail. This is kind of standard idea of development. Coding to build a brain is in the DNA, apparently. Brain runs the endocrine system. Endocrine system dictates how the DNA is read. So it's kind of a closed loop. Most of the variation comes from the DNA. That's the standard theory. I think it's a good theory. It maybe doesn't explain everything, but it is a good theory. And what you've put into the loop doesn't have a great impact on how the DNA is read. Some, but not much. Except when you do this. When you start adding in the sex hormone compounds of a whole other kingdom. This will definitely mess with the DNA. Directly, and also by altering our own hormones. Changes the way the DNA is read. And all the evidence I've come across from the pharmacological literature is it has a juvenilizing effect. It stops us maturing in the way we used to. And you might think, well, we're supposed to mature. that's the normal thing, and I agree that is the normal thing with mammals. But I think what set us apart was our maturation was slowed down and almost stopped, held in stasis, allowing us to grow this huge brain, juvenile tissue with all these amazing traits. And I think that was the mechanism that allowed it to triple in size in such a short time in the forest. Yet we're told about the evidence that's been found outside the forest. Oh, well, we found evidence of hunting or fire or whatever. Yes, absolutely. But the presumption is that every fossil that we found outside the forest is telling us about the whole lineage that may well still have been in the forest. It's equally possible to interpret this. I found no contradiction that what we see outside the forest is simply a snapshot of what was going on in the forest. Refugees from the forest, they come out, we find evidence of them. Okay, the brain was getting bigger. But there's nothing to build the brain in these kind of harsh climates like the savannah and so on. All the stuff you need to build and run a brain is in here. And then climate change, lose the tropical forest, come out the forest or the forest disappears. You're highly intelligent, you can survive, that's not a problem. And intelligence allows you to survive eating fallback foods and eventually other things. But the chemical formula to protect this juvenile brain is gone, and it stops. It stops expanding, it starts shrinking. And a big twist in it all, and the evidence is good for this now, our brain, left and right side of our brain, are genetically asymmetric. Each side is genetically a little bit different, probably for very good reasons a long, long time ago. This stuff has the capacity to iron out those genetic differences by never allowing them to be expressed. So when you think about children, they have a fairly symmetrical brain. It only starts becoming asymmetric when the sex hormones kick in. Then women have a more symmetrical brain than men because they're exposed to less testosterone. They are exposed to some, so there's a bit of asymmetry creeping in there. And by the time you get to the male brain, much more asymmetric. But I think the real nature of the asymmetry isn't about specialized adaptation anymore. It's about the degree it's reverting to a more primitive form. That's the nature of the asymmetry now. And I think it's a much easier explanation, this ballooning, this rapid expansion, stall, shrinkage, in a very, the blink of an eye in evolutionary terms. I think it's the mechanism that explains why we've slowly been going mad. We've lost this juvenile phase, and it's happening before our eyes. Again, I'm sure a lot of you here have read the age of sexual maturation in humans is shrinking. Even in the last 100, 150 years, you're looking at 10, 15%. That's the window that the big brain grows. It's shrinking before our eyes. We should be extremely alarmed because every generation that goes through that, it's less time to build a big advanced brain. The window's shrinking, and each generation we're losing, and it's accelerating. And of course, each generation, this is handed down through the female line. As the brain changes, it's running a more primitive endocrine system. This influences the next generation, and so the cycle speeds up. In exactly the opposite way we had rapid or accelerating expansion, we're getting slowly into accelerating degeneration and shrinkage. How are we doing for time? 5 minutes. Yeah, and very briefly, I mean, again, these are hailed as great advances. Well, in terms of survival, yes, but in terms of the impact on our brain, not such a good idea. No chemistry in this by comparison to the forest, chemically very impoverished. In fact, it's one of the reasons I think we self-medicate so much, or we're desperate to self-medicate. Our advanced neural system evolved in one of the most chemically complex ecologies we know. That's its operating system. It's supposed to be flooded with chemicals from the plants. Now it's not. So, of course, we're reaching out for all sorts of stuff. Some are very detrimental, but it's no surprise we're reaching out, trying to self-medicate because our brain's starved of chemistry. It's chronically deficient, and yet we legislate against self-medication. And then we get to this, where we start building our brain with this kind of stuff. And we jokingly call it junk. We think it's kind of funny. Most complex thing we know, central to everything we do, every decision we ever make, and we're now building it from this. Not very good. As ever, there's so much more I could say. I know I've got a short window here. I hope it's given you a little taste of some of the areas I've been looking at. I will say that once you assimilate the diagnosis, the idea that we were held in a juvenile state, we grew this phenomenally unique brain, and now it's reversing. Once you understand that, you can start to see ways to fix it. There are ways to sort this out. We already know a lot. The biggest challenge is recognizing the seriousness of the problem. I would suggest if you get time, have a look online. I've got YouTube stuff which fills in a lot of the blanks. I have got copies of a book which again cover all these areas if you want to investigate further. I'm going to stop now because I've hit you with a lot of concepts. You're probably feeling a bit overwhelmed. I've spent 20 odd years developing a concept. Even if it turns out to be partially accurate, it's still just a concept, it's still just a map. And what I'm really interested in is creating a map where we feel compelled to change the structure and therefore change our experience. So what I'm going to do for the last few minutes, very quickly, I'm going to ask Matthew if you could just turn the lights up ever so slightly. And I'm going to invite you, big change in direction here, just to mess with your heads a bit more, to take part in a little exercise. Maximum 5 minutes, absolute maximum. It's entirely your choice, but I suggest it's a quick reminder of our humanity and what really is important instead of all the concepts we're chasing, even if they turn out to be useful. So I'm going to invite you to pair up with someone, probably the person you're sitting next to. As I say, if you feel too uncomfortable, it's okay, but you might want to ask why. And for no more than 5 minutes, that's all I'm asking, 5 minutes, 3 minutes maximum. If you could turn to your selected partner, if you've decided to do that, and just relax in a meditative style and look into their eyes. That's all I'm going to ask you to do. Preferably quiet, just relax. No need for all that left brain chatter. 3 minutes if you can manage it. Just relax, look into someone else's eyes. And I tell you what helps, if you can dare do it, is smile a little bit. It changes things. And it's not a staring competition. It's really about allowing yourself to be seen. I know that's scary, but I promise nothing's going to happen. Just relax and allow yourself to be seen. And you might be surprised. Okay, we'll let you off the hook now. I think it's time to move on. Sorry for the rushed presentation. There's so much I'd like to say, but it's a very short. Thank you very much.